to compare the EMFs of two given primary cells, Leclanché and Daniell cells, using a potentiometer. Stretched wire potentiometer consists of a wooden base over which 10-meter long resistance wire of uniform cross-section is fixed in 10 rows. Two binding screws are fixed at the ends of the wire. A jockey is provided over the wire so that any point of the wire can be electrically connected to the jockey. One leg of the jockey slides over a metal strip. Two binding screws are provided at the two ends of the metal for connection with the circuit.
Madam, how can we compare the EMF of two given primary cells, Leclanché and Daniell cells, using a potentiometer?
When a constant current flows through a wire of uniform area of cross-section and composition, then the potential drop across any length of the wire is directly proportional to that length. That is, V proportional to L, or V is equal to KL, where K is the potential gradient in the wire. If L1 and L2 are the balancing lengths on the potentiometer wire, corresponding to two primary cells of EMFs E1 and E2, then E1 is equal to KL1 and E2 is equal to KL2. Therefore, E1 by E2 is equal to L1 by L2. Let's do an experiment to compare the EMFs of two given primary cells, Leclanché and Daniell cells, using a potentiometer. Our aim here is to compare the EMFs of two given primary cells, Leclanché and Daniell cells, using a potentiometer. Apparatus required are potentiometer, a Leclanché cell, a Daniell cell, an ammeter, a galvanometer, a battery or battery eliminator, a rheostat of low resistance, a resistance box, a one-way key, a two-way key, a jockey, a set square, connecting wires and a piece of sandpaper. Procedure: draw a neat circuit diagram, measure the EMF of the battery E and the EMFs of two given primary cells E1 and E2. See that E is greater than E1 and also E is greater than E2. If it is so, then start your experiment. Remove the insulation from the ends of the connecting wires with the help of sandpaper. Connect the positive pole of the battery of constant EMF to the zero end A of the potentiometer wire and the negative pole through a one-way key, an ammeter and a low resistance rheostat to the other end B of the potentiometer wire. Connect the positive poles of the cells E1 and E2 to the end A of the potentiometer wire and the negative poles to the terminals A and B of the two-way key. Connect the common terminal C of the two-way key through a galvanometer G and a resistance box RB to the jockey J. Take maximum current from the battery making rheostat resistance 0. Insert the plug in the one-way key K and establish a flow of current in the circuit, and also insert a plug in between the terminals A and C of the two-way key. Take out a 2000 ohm plug from the resistance box RB. Press the jockey at the zero ends and note the direction of deflection in the galvanometer. Again, press the jockey at the other end of the potentiometer wire. If the direction of deflection is opposite to that in the first case, the connections are correct. If the deflection is in the same direction, then either the connections are wrong or EMF of the battery is less than the EMF cell. That is, E is less than E1. Check the connections and repeat the action. Slide the jockey gently over the potentiometer wires till you obtain a point where galvanometer shows no deflection. Put the 2000 ohm plug back in the resistance box and obtain the null point position accurately. using a set square. Now remove the plug in between the terminals A and C and insert it between the terminals B and C of the two-way key. Repeat the steps 9, 10 and 11. Now change the current flowing through the wire of the potentiometer by adjusting the rheostat and obtain 3 more sets of observations. Record all observations in a tabular form. Observation: range of voltmeter is equal to x volt. Least count of voltmeter is equal to x volt. EMF of the battery E is equal to x volt. EMF of the cell E1, Leclanche cell, is equal to x volt. EMF of the cell E2, Daniell cell, is equal to x volt. Least count of ammeter is equal to XA. Zero correction for ammeter is equal to XA. Table for balancing lengths L1 and L2. Serial number. Corrected ammeter reading A, ampere. Balancing length when Leclanche cell E1 is in the circuit L1, centimeter. Balancing length when Daniell cell E2 is in the circuit L2, centimeter. Ratio E1 by E2 is equal to L1 by L2. Result: the ratio of the EMFs of the two given cells is X. Precautions: all the connections should be neat, clean and tight. All plugs of the resistance box should be tight. The plugs should be inserted in the keys only when the observations are to be taken. It should be checked properly that the EMF of the battery E should be greater than EMF of the two given cells separately, that is, E is greater than E1 and E is greater than E2. All positive terminals should be connected at zero ends A of the potentiometer wire. The jockey should touch the wire gently. The balancing length of the wire should be measured from zero ends A of the wire. The rheostat should have a low resistance. Make sure that ammeter reading should remain constant during one set of observations. Sources of error. The potentiometer wire may not be of uniform area of cross-section. The EMF of the battery may not be constant. The end resistance may not be zero. There may be a change in resistance due to heating of wires when continuous current flows through the wire.
Thank you, ma'am, for this knowledgeable experiment.